Hello, my name is Juliam Rodriguez, and I will now be discussing the video for the shortest path routing project, which is project 3 on our networks class. So let's go ahead and discuss what it's about. So the shortest path routing problem is simply to find the shortest path from one place to another in a weighted graph, or each source and destination have a certain cost to reach that destination. So let's say from Washington to Illinois, that cost is going to be 2,400. So the professor wants us to find uh, the shortest path from New York to California 2, Washington to Georgia, and California 1 to New Jersey. So the first thing we can see here is that there are no negative values on the weights. So that means that we can use Dijkstra's algorithm, which is a pretty efficient algorithm to use. And we don't have to go and deal with A star, for example, and use the heuristic function, which we would have to define if we would want to use it. And we would pretty much get the same time complexity as we would get on Dijkstra's. And then Bellman-Ford and Floyd-Warshall will be used more for negative weights. So let's go ahead and jump into the code. The first thing that I did was translate the graph that the professor gave us into a dictionary. So the keys are nodes, and each one of the keys have values, and the values are each one of the destinations that that certain node can reach. So um, in each destination, you will have a number, and this is the weight, or meaning what it costs to reach that destination. So for California 1 would be 1050, California 2 would be 1500, and for Illinois would be, as we just previously discussed, 2400. Um, yeah, and it's the same thing with each one of the keys or nodes, and all of them have their own destinations. So with the Dijkstra's algorithm is right here, and as we can see, we have a heap or a priority queue. We have the visited set, and we have an order list, which is simply something for added value at the end when we get the results. It doesn't really involve the algorithm at all. It's just something I added. So let's go ahead and see how it works. So we first initialize the heap, and we give it the starting node. So as long as the heap has something inside, then this loop will continue to iterate. So we get the cost, the node, and the current pass would be which would be an empty list from the heap. So we pop the start node right here, and if that node is visited, then we want to continue, move on to the next one. In this case, it's not visited, so we'll continue. So we add the path that we have, or to the path that we had, the node that we are in right now. So that's part of the path. And then if the node is the end, then we want to return, because since this is using a heap, we don't really need to go ahead and visit anything else, because we know that if we found the end, then it's going to be the most optimal path. So we add the node to the visited set, and then for every neighbor that that node has, and it's not visited, we want to add that to the heap. The heap will always be efficient in the sense that it will always put on the top the one that we need. And then we simply iterate through everything and keep incrementing the cost as we go with the path. Eventually, we will reach the end. And once we do that, we will get the cost, the path, and the order of all the visited nodes that Dijkstra used in order to reach there. So I defined here our paths, which is New York to California 2, Washington to Georgia, and California 1 to New Jersey. And each of them calls Dijkstra. So let's go ahead and run this cell and see what we get. So I did this a little bit of data visualization here, just so it's easier for us to see. So as we can see, for each route, we get the result. It says that for New York to California 2, our total cost is going to be 3,000. Well, near California 2 is right here. I kind of changed it by accident. But it's going to be 3,900. And the path is going to be New York, DC, Texas, and California too. So if we go back to um, our original graph here, it's going to be New York. Um, I want to say it was Pennsylvania. No, it was actually New York, DC, Texas, and then California too. There, Pennsylvania has nothing to do with it. So I think that's going to be right here. New York, DC, Texas, and California too. Correct. So for Washington to Georgia, it's going to also be 3,900. It's going to be Washington, Illinois, Pennsylvania to Georgia, and then California 1 to New Jersey is going to be California 1, Utah, Minnesota, and New Jersey. And then this is every single node that the algorithm visited before finding the correct destination. So I actually implemented this script that helped us visualize everything. So let's just run that. And then we have to first put in where we want to start. So let's go ahead and pick one of the options. And one of them was Washington, and the destination was Georgia. And that's going to run for a second here. And then we can see how the algorithm pretty much works, right, as it's going. So if we want to press play, we're just going to watch it go ahead and start exploring around until it reaches its optimal path. And that takes 13 steps. So if we play press, it's going to start visiting. Yep. Wonderful. So the path that we got was Washington, Illinois, Pennsylvania, and Georgia, which is the result that we got up here, which is Washington, Illinois, Pennsylvania, and Georgia. And if we go one by one, then all of these are going to be visited by our little animation here, which every visited node is marked by red, or the edges are marked by red, and then all of them are connected to a visited node. So let's go ahead and do New York to California too. Let's run this again, and let's do New York to California too. And now we have the starting node being New York, and then we're going to see how much it's going to cost to reach there. So as we said before, it's also 3,900, just as Washington to Georgia. And the path is New York, DC, Texas, and California too. It takes 13 steps to get there. And then the last one would be California 1 to New Jersey. And we're supposed to get 3,450. And then California 1, Utah, MI, and New Jersey. And then these are the ones that we're going to visit while we explore the entire graph. So let's go ahead and try it. So we have California 1 and New Jersey. So now we start in California 1. And we're going to start it. So California 2, Utah, Washington, Colorado, NE, Texas, Illinois, MI, Georgia, New York, New Jersey. So this is the algorithm. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so this is equivalent to the path that we just followed. Yeah, and the path is California 1, Utah, MI, and New Jersey, which is the same one here. Right, Utah, MI, and New Jersey. And there we have it. That's we also got the 3450 on the weight, and that's Dijkstra for you. That's the representation of it. Thank you very much for watching.